Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about selection sort and bubble sort, the two applications of brute force technique. First, we are going to see selection sort. Selection sort is a simple and efficient sorting algorithm that works by repeatedly selecting the smallest or largest elements from the unsorted portion of the list and moving it to the sorted portion of the list. It goes for selecting either smallest or largest elements from the unsorted portion, and it arranges these smallest or largest elements to the sorted portion. The algorithm repeatedly selects the smallest or largest elements from the unsorted portion of the list and swaps it with the first element of the unsorted list. This process is repeated for the remaining unsorted portion until the entire list is sorted. Here you can see algorithm for selection sort. So here the first step is for I is equal to 1 to n minus 1. We have to repeat the execution of some statements. The first statement is we taken a variable minimum which is initialized with I. For j is equal to I plus 1 to n. So why we have taken here I plus 1 means here we are comparing the elements from the next element what we selected earlier. Here we have taken minimum is equal to I. That is initially I value is 1. Minimum contains 1. From I plus 1 we are going to searching. That is find the index of the ith smallest element. Now if a of j is less than a of min, then min is equal to j. That is the min value is updated to j. That is whichever is the minimum value. If a of j is less than a of min means the element which is present at jth index is less value. So the minimum value is updated with that jth index. And whenever we find a minimum value, then the a minimum and a of I can be swapped to each other. Now you can see the procedure of this selection sort, how it works. Now let us take a list of elements. Totally I have taken 5 elements. These 5 elements are 64, 25, 12, 22 and 11 which are unsorted. In the first pass of the algorithm, for the first position in the sorted array, the whole array is traversed from index 0 to 4 sequentially. The first position where 64 is stored presently. After traversing whole array, it is clear that the 11 is the smallest element. That is 11 contains 11 is the smallest element which is present at 4th position. Thus, replace this 64 with 11. After one iteration, 11, which is the least value in the array, tend to appear in the first position. After the first pass, 11 comes to the first position and 64 comes to the last position. That is, the swapping is happened. Now, coming to second swap. In the second swap, at the second position, we identified an element 25. We need to traverse the entire list. When we traverse the entire list, we find the next least element is 12. Now, this 25 is swapped with 12. Now, 11 and 12, both are sorted. This is the sorted list. Now, in the remaining sorted list, we are going to compare the 25 with 22. Now, both 25 and 22. Now, here 22 is the minimum element. When I traversed the list, 22 is the minimum element. This 25 and 22, both are swapped. Now, I get a sorted array up to 11, 12, 22. When I traversed the remaining portion of the element, 25 itself is the smallest element and 64 is the largest element. So the array is already sorted. Now, finally, after 5 passes, we will get a sorted array. Now here you can see one more example for selection sort. Here in this case, 8, first element is 8. So when I traversed the remaining list, 8 itself is the smallest element. So no need of swapping. Second element, 12. When I traversed the remaining list, itself is the smallest element. Now, when I go to the third element, when I compare the third element with the remaining, here 17 is the smallest element. So 17 and 25 are swapped. Right. When I am going to the fourth element, 29. So when I traversed the remaining list, I found 25 as the smallest element. So 25 and 29 are to be swapped. Now, when I am coming to the next element, 32. So if I traversed the list, we find that 29 is the smallest element. Now 32 and 29 are swapped each other. When I considered 32, remaining elements are 40 only. That 40 is greater than 32. So no smallest element than 32. So that's why the sorted array is like this. Now coming to the complexity of selection sort, the best case complexity of selection sort is big O of n square. Average case is also big O of n square, whereas the worst case time complexity is also big O of n square. So why? Because this is the brute force approach. We are not following any strategy to identify, to sort the list. We are following sequentially. We are checking each and every element. Every time we are traversing the remaining unsorted list. Since it is the brute force approach, its time complexity is big O of n square. Coming to the next application, bubble sort. Bubble sort is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in the wrong order. This algorithm is not suitable for large data sets as its average and worst case time complexities are quite high. This algorithm traverses from left and compare adjacent elements, and the higher one is placed at the right side and lower one is placed at the left side. In this way, the largest element is moved to the rightmost end at first. This process is then continued to find the second largest and place it, and so on until the entire data is sorted. Here you can see algorithm for bubble sort. So here we are taking input data A, and what we get is sorted list of A. We taken three integers I, j, k. So now here n is equal to length of A, that is the total number of elements which are present in A. Now we have taken two for loops for one, j is equal to 1 to n, and for I is equal to 0 to n minus 1. And if A of I is greater than A of I plus 1, if A of I is greater than A of I plus 1, that is the two successive elements are compared. When I is equal to 0, A of 0. When I is equal to 0, A of 1. That is A of 0 is compared with A of 1. So if A of 0 is greater than A of 1, we swapped those two elements by using a temporary variable. So like that, this process continues till all the elements are swapped and they are arranged in the swapping order. Now coming to the example, in the first step, here we have taken an example list which contains 4 elements. Those 4 elements are 6, 0, 3, 5. So first, in the first iteration, the element 6 is compared with its next element 0. Now these two are swapped. 0 comes here and 6 comes here. Next 6 is compared with 3. Now 3 and 6 are swapped. Since 6 is largest, it comes to the right side. So 3 and 6. Now 6 is compared with 5. Now since 5 is less, these two are also swapped. Now we will get, after the first pass, we will get the array as 0, 3, 5, 6. Now, so here we find that the array is sorted for the given list. But always this may not be case. Sometimes we may get unsorted array. Here I will get the largest element. Now in the second pass, we will compare 0 and 3. So they are in the correct order. We will compare 3 and 5. They are in the correct order. We will compare 5 and 6. They are in the correct order. Now in the third pass, 0, 3 are compared. Next 3, 5 are compared. And 5, 6 are compared. Now we will get a sorted array. Let us see one more example. Here you can see in the first pass, 7 is compared with 6. Both are swapped. 7 is compared with 4. Both are swapped. 7 is compared with 3. Both are swapped. You will get 6, 4, 3, 7. But here the array is not sorted array. This is just we get the largest element at the end of the array. Now in the second pass, this becomes the input. Now these two are compared, 4 and 6. Next these two are compared, 3 and 6. Next these two are compared. Right. These two are, when I compared these two, the same list I contain, I'll get. So that's why now the second largest element is present in its correct position. Even now the array is not sorted. This becomes the input for the third pass. Now 4, 3 are compared. Now these two are swapped, 3 and 4. Now the third largest element comes to its place and I get the sorted array. Right. Like this, the bubble sort works. Coming to the time complexity, the best case time complexity of bubble sort is big O of n. Average case time complexity of bubble sort is big O of n square, whereas the worst case time complexity is big O of n square. So you've seen two cases. So first one is the first example, what you've seen is the best case complexity. The worst case is the next example, what you've seen is the worst case complexity. Right. So I hope that you all understood both selection sort and bubble sort. Thank you for listening the session.